Assalamualaikum and good day, student. Continue with the video 2. What we have here now is a simple problem solving. So let's say this is a system with a four blade. 2 is the imaginary blade, while B and C is already fixed. The question is asking to locate and determine a suitable mass A and D for a complete balance. So in a way of a graphical approach. So let's say the mass of A, this is the one that we want to know, and then this is mass D, how much, given the radius is R equal to 1 meter, same applied to D. So A and D is an imaginary blade. So it is since it is a dynamic balancing, because of the blade is located at a different plane. So individually is located, A and B is 1 meter, B to C is 1 meter, and C to D is 1 meter. First, when you are dealing with a graphical approach, you need to do a summary table. So what we have here is basically a column of a blade A, B, C and D. The mass itself, so mass B and C is known, while mass A you don't know how much, and mass D also you don't know how much, but the radius is all the same, at 1 meter individually. And then the distance, I mean the length measured from a reference plane. So we are taking plane A as a reference plane. So this one is 0, B is 1 meter. So mass C referring to the plane A is 2 meter, and then mass D referring to plane A is 3 meter. So angle measuring from X axis, A is you don't know how much, B is actually 90 degree, and then C measuring from positive X axis is 180 degree. So mass D we don't know how much. So you need to put a column of M times R plus additional MRL. We are leaving omega behind because of a few later we will look into this. So this is representing the force, this is representing the moment or couple. So what we have here is so since we are taking plane A as a reference plane, so the value, the magnitude of moment for plane A is already considered as 0. So you have 3 variable over here: moment of A, moment of B, moment of C, and moment of D. So we are expecting to draw a moment polygon by using this 3 value. So having this value of moment, so you need to draw a moment polygon using a scale like say 0.5 kgm squared is equal to 50 meter, and considering blade angle, construct the moment polygon. Start from B, so the value is 0.5. So this is MB, RB, LB. This is moment for B, and then this is moment for C. So you don't know how much is the value of D, but you know that keep in mind that by having the moment polygon close, you will have the system is dynamically balanced. So drawing the additional line from C to B will representing the value of moment for D. So this is the new angle direction of the blade D. So by measuring the distance of line of moment D, you will have the magnitude of 1.112 kgm squared, and then you can reveal that the MR is 0.373, since L, you know, that is equal to 3 meter, and then you will know that the mass is 0.373 because of R, you know, that is 1 meter. By measuring the angle of this one, so you notice that the angle is actually 333.5, measuring from positive x-axis. So this is the new mass for D, mass D, with an amount of 0.373 kilogram at the angle of 333.5 just now. Okay, the next one is you need to do the force polygon. By having this variable over here, so you need to construct the force polygon using a scale of 0.5 kgm squared is equal to 50 meter, and considering blade angle, construct the force polygon start from P. So this is the value that you want to look for, value of A. Start with B, 0.5. This is the vector of force for mass B, and then followed by C. This is the force, centrifugal force by mass C, and then followed by 0.373 kgm, centrifugal force of mass D, with the same within the same direction. So this is the vector. So you already draw three magnitude of force over here, vector over here. So you need to draw another line from mass D, from vector D to vector B, to reveal the value of mass A. So this is representing the length of the red line length is referring to is representing the value of the centrifugal force of A. So this is the new direction, this is the new orientation of mass A, and then by measuring you can reveal that the mass A is actually, the amount of M times R is actually 0.373, but since the R is only 1 meter, so you get the value of mass A is actually 0.373 kilogram. So measuring the angle from positive x-axis towards the mass of A, so you reveal the degree is 296.5. So the final blade's orientation will become like this. So this is mass B, 90 degree corresponding to C, and then it looks something like this. We say D, mass D, from the orientation of mass D is 333.5, while this one is 296, if I'm not mistaken just now. So that's all. Thank you.